Good afternoon. My name is Dr. Carolyn Brumley, Victoria's Acting Chief Environmental Scientist at EPA, and it's my pleasure to welcome you online today to the Environment Protection Authority Victoria's first Environmental Science Seminar Series event for 2021. This event focuses on stormwater management, and we are very pleased to welcome a special panel of guest speakers with us from the University of Melbourne, Associate Professor Chris Walsh, Professor Tim Fletcher, and Dr. Stephanie Laval. I would like to begin by acknowledging the Aboriginal people as the first people and traditional custodians of the land and water on which we live, work and depend. We pay our respects to Aboriginal elders past and present. As Victoria's environmental regulator, we pay our respects to how country has been protected and cared for by Aboriginal people over many tens of thousands of years. We recognise the unique spiritual and cultural significance of land, water and all that is in the environment, and the continuing connection and aspirations for country of Aboriginal people and traditional custodians. A few notes on this live stream event. The structure of today's events will feature an introduction by myself, short presentations by all three panellists, time for Q&A, and wrapping up with a conclusion. This event will be recorded, so if you need to leave early or miss parts of this session, you can watch it again later via the EPA website. This session has live closed captions to ensure it's accessible for all. We will provide time at the end of the Q&A session, and we welcome people to please ask questions using the box at the bottom of the screen. The Q&A will be open throughout the event, but we will respond to questions after the presentations. We will try to get to as many as we can, and all questions not answered today will be responded to via email at a later time. So please provide your contact details so we can respond to you. Today, we are here to discuss urban stormwater management. When rain falls on your home, business or garden, it runs into your downpipe and into the nearest stormwater drain. The stormwater system is designed to prevent urban flooding by directing stormwater into the nearest creek, river, lake or bay. There are more than 300 stormwater outlets to Port Phillip Bay alone, as well as outlets to Western Port and many creeks and rivers throughout the state. There are two main challenges with stormwater. One, the large volumes of stormwater that run off hard surfaces such as pavements and roads. And two, that stormwater carries pollutants like bacteria, litter, sediment and oil. Stormwater is the major cause of pollution of Victoria's waterways. Over the last year, we've all spent more time at home. We've spent more time exploring our neighbourhoods and walking along local waterways and beaches. I think for many people, this experience has highlighted the importance of protecting our environment from pollution and waste. Perhaps you've noticed litter or an oily sheen, pet droppings, or even concrete in your local waterway. These are common pollutants you may find in our waterways. Other common stormwater pollutants you can't see include garden pesticides, harmful microorganisms from soil or animal droppings, and toxic heavy metals. These pollutants can make our waterways and beaches unsafe for swimming and can seriously harm our environment in many ways, from nutrients causing excess plant growth that chokes our waterways, to heavy metals and toxins causing adverse effects in animals that call these places home. This is a significant issue for Victorians. Every month, EPA receives approximately 200 notifications from community members of pollutants entering waterways via the stormwater system. Notifications include discharges to waterways that are coloured, cloudy, odorous and oily, sometimes associated with visible harmful effects such as fish deaths. Large volume stormwater flows present challenges in their own right by scouring stream beds, moving water too quickly away from where it falls and transporting pollutants from the land to our waterways. As our urban areas grow and our climate changes, the challenges on our stormwater system and how we manage stormwater will become greater and more complex. In a warming climate, the benefits to community well-being of retaining water in our urban landscape is gaining increasing attention. Stormwater can also provide an alternative water supply suitable for garden watering and toilet flushing. At EPA, our purpose is to protect the environment and human health by preventing or reducing harm from pollution and waste. The best way to reduce the impacts of stormwater pollution is to stop the pollution getting into the stormwater system in the first place. community, business and government all play a role in reducing sources of pollution and waste to stormwater. As community members, we can all help prevent pollutants from reaching local drains and can improve our creeks, rivers and bays. Reducing stormwater pollution can be as simple as washing your car on the grass or at a car wash that recycles water, always putting your litter in a bin, cleaning up after your animals, and cleaning paintbrushes in a sink so they don't contaminate stormwater. EPA is responsible for regulating pollution and waste entering waterways. We do this through environmental laws, policies and regulatory controls, and by working in partnership with Victorian communities, water authorities, businesses and government. EPA undertakes monitoring of ambient and recreational water quality during summer as part of its Beach Report and Yarra Watch programs. These help the community make informed decisions about swimming and other recreational water-based activities during summer. Sampling has shown that water at the Bay and Yarra River sites meet the standards for swimming 98% and 84% of the time, respectively. Stormwater pollution following rainfall contributes to not meeting these recreational water quality guidelines. EPA works closely with local councils to improve the environmental management of urban stormwater. Actions such as water-sensitive urban design, investment in rain gardens, sediment ponds and wetlands can improve the quality of stormwater entering our waterways. EPA works with local councils to provide them support and guidance on how to manage stormwater. In 2019 and 20, EPA expanded its Offices for the Protection of the Local Environment, or OPLE, OPAL. This is a pilot to cover 23 councils with 19 EPA authorised officers embedded in our communities. The OPAL program has delivered fast responses to local environmental issues, such as resolving noise complaints, reducing stormwater contamination and litter. EPA also works closely with the Department of Environment, Land, Water and Planning, or DELP, who are responsible for the broader statewide strategy for managing stormwater. Integrated water management, where all sources of water are considered, including stormwater, is seen as crucial to make our cities and towns resilient and livable for the future. Planning codes are also crucial, with developers looking to the Victorian planning provisions for the rules they need to comply with in any development. For Melbourne Water, in their role as catchment manager, are responsible for the health of our waterways. Their recent Healthy Waterways strategy renewed its focus on reducing the impact of stormwater, especially in high-value waterways. EPA continues to conduct research into many aspects of stormwater. This research includes investigating new sensors to better inform us in real time when pollution is occurring, and better defining the sources of pollutants such as bacterial contamination at our beaches. EPA is developing new best practice guidelines on urban stormwater management that will apply to more land uses such as commercial and industrial premises. A significant addition to the draft guidance is the improved flow standards, which aim to reduce large stormwater volumes which flow off hard surfaces such as roofs, driveways and roads. This is an opportunity to include updated scientific knowledge of urban stormwater and bring the guidance in line with community, business and government expectations and Victoria's new environment protection legislation. As Victoria adapts to a growing population, a changing climate and a revised industry profile, EPA and the Victorian community are faced with more complex environmental and human health challenges, including the protection of our waters from polluted stormwater. This updated guidance is essential to help improve the management of stormwater so we can protect our environment and human health from the impacts of pollution and waste. On this note, I will hand over to our MC for this event, Leon Metzling. Leon is a senior applied scientist in EPA's Applied Science Division, specialising in inland waters. He's been with EPA for over 30 years and has led the development of significant pieces of work to protect our environment and human health. Leon is leading the science input to the review of the best practice guidelines on urban stormwater management. He has addressed many aspects from stormwater in his time at EPA and continues to be involved in research on stormwater impacts. Leon has over 40 publications in the peer-reviewed literature focusing mainly on freshwater ecology and bioassessment, but has recently focused on the impact of emerging contaminants on aquatic systems and human health. Leon is a wealth of experience and knowledge and has organised the fantastic panel you see here today. Over to you, Leon.
Thanks, Caroline. It's indeed my pleasure to be emceeing this seminar as I consider the broader issue of stormwater to be the major threat in our waterways, and one that we have as a society have yet to address properly. People do have a complex relationship with water. While we recognise the crucial role and the importance that water has in life and the premium we're willing to pay for having a view of water, we also don't want too much of it around. Floods are not a good thing, and as Caroline mentioned, moving floodwaters away has seemed to be a priority. But there are consequences to this, and consequences that have not been sufficiently well acknowledged nor acted upon. I suspect that stormwater has been a problem ever since people started ploughing the land and building houses, but it's probably reached its low point with the quality and quantity of stormwater from our cities and towns. Now, two of our speakers, Chris Walsh and Tim Fletcher, have spent many years looking at the ecological and physical aspects of stormwater and are well placed to talk about the problems and the solutions that we need to be thinking about and addressing as a society. It is a big problem, but I do feel that there is momentum. Some of the high-level strategies in Victoria, such as Water for Victoria, Integrated Water Monitoring Framework, Melbourne Water's Healthy Waterways strategies, they've all acknowledged their problem and are coming up with ways to tackle the stormwater problem. EPA, as Caroline mentioned, is renewing our guidance and hopefully we'll be incorporating improved stormwater flow standards into the new guidance. Now, while standards are important, they'll come to nothing unless people adopt them and change their behaviour towards how they think about stormwater. And this is where the work that Stephanie Lavau, our third speaker, is well placed to answer, looking at the drivers of people's behaviour and their adoption or not of some of the technologies we need to improve management of stormwater. So on that, I'll hand over to Chris. It'll be our first speaker. He'll start us off by talking about what we need to do in order to protect our Victoria's streams and bays. We'll then move on to each of the next speakers in turn. I'll encourage you all to start recording questions as each of the speakers are talking and put them into the online system. And they'll all come to me and I'll ask them at the end of the session, at the end of the speaking session. So with that, I'll hand over to you, Chris.
Thanks very much, Leon, and thank you to Caroline for the invitation. And I should start by thanking both Leon and our colleague Yung En Chi at the University of Melbourne, who were really the primary drivers of getting the three of us here today. And it wouldn't have happened without you both. So thank you. No worries. Thank you. So today I'm hoping to convince you of four things. Firstly, that the State Environment Protection Policy objectives, the SEP objectives for streams and rivers are pretty good. They have a strong ecological underpinning and they are useful for alerting us to streams that have problems. One of the major persistent problems for streams in many parts of the state is the current dominant approach to urban stormwater drainage practice, which erodes, pollutes and degrades streams, as Caroline was telling you. Current and even the proposed standards for better stormwater practice don't really cut it. They're not adequate to arrest the degradation of the state streams and they don't link to the SEP objectives. However, we have developed, tested and implemented alternative objectives that are well accepted by the community, that can protect and restore stream health and can be directly linked to SEP objectives to guide drainage practice for true stream protection. So I'll take you through each of these 4 points in turn. I'm going to anchor today's talk around reaches on 4 streams in the east of Melbourne. So first, a brief orientation. I'm going to begin by contrasting 3 small streams that rise in the Dandenong Ranges as they were 10 years ago. BRS's Brushy Creek, it's a degraded urban stream draining the suburbs of Mooroolbark and Croydon, and about 25% of its catchment's covered by roofs and roads, or at least they were in 2009, where I'm drawing these statistics from. Sassafras Creek, SAS, Little Stringybark Creek is where I'm going next, isn't it? LIS, it's also a degraded urban stream, rising in the suburb of Mount Evelyn, but then flowing into the rural residential areas of Wallan. At our sampling site that we've been sampling for many years, about 12% of its catchment's covered by roofs and road. They were in 2009. Sassafras Creek, at last, is a healthy forested stream that you might be surprised to learn is also an urban stream. It drains the township of Sassafras, and at our sampling site, about 8% of its catchment is covered by roofs and roads. So Little Stringybark Creek and Sassafras are both moderately urban catchments, but they're in very different conditions. Sassafras is in very good condition, Little Stringybark Creek is degraded. We'll come back to why that might be in a minute. I'll also show you some data from YAR, the Yarra River at Fitzsimons Road, Templestowe. This site's downstream of these three streams, as well as downstream of Mullamullum and Diamond Creek that drain large areas of urban land. So it's a good integrator of the story of these three streams. It's important to realise that none of this area upstream of Fitzsimons Road there in the Yarra catchment to the east of Melbourne seen a lot of urban expansion in the last 20 to 30 years, not much urban expansion at all. Most of the urban growth's been infill development, of which there's been quite a lot. So the State Environment Protection Policy objectives for rivers and streams provide solid defensible targets for healthy waterways in Victoria. They've got a good basis in ecological theory, and that is that biological communities that we find in our streams are the product of the quality of their dominant ambient conditions together with disturbances to those conditions. So in stream and river ecosystems, this means that for most of the time they experience flowing water of good quality, with occasional disturbances to the flow, whether it be drying or flooding, which can then temporarily worsen water quality. So that's a natural condition for streams. So the SEP the SEP for rivers and streams has two types of objectives. First, there's the water quality objectives, and so here, for an example, we've got the objectives for total phosphorus for the Yarra catchment, and there's a slightly different objective for lowland streams versus upland streams that you can see there. And we've got the actual 75th percentile concentrations for total phosphorus for our three streams here, for Sassafras Creek, for Little Stringybark Creek, and for Brushy Creek. So our healthy urban stream, Sassafras Creek, easily meets the objective for total phosphorus, whether it be considered an upland or a lowland site. It's sort of on the border there. Our similarly urban but less healthy urban stream, Little Stringybark Creek, it's not being so remarkable now. No, come on, you can do it. Little Stringybark Creek just fails to meet the total phosphorus objective. And the more heavily urbanised stream, Brushy Creek, doesn't even come close to meeting the objective. So these objectives are very useful for us being able to differentiate levels of degradation. The other type of objective is biological objectives, and so this one is so biological objectives assess the composition of species living in the stream. So they're powerful objectives because the in-stream biological community is a product of past conditions, both ambient condition and disturbances in the stream. So this is Signal Score. It's an index based on invertebrate families found in the stream. And it tells a similar story to the total phosphorus objective. Sassafras Creek easily meets the objective, Little Stringybark Creek's a borderline fail, and Brushy Creek is a comprehensive fail. Now there are several lines of evidence that point to the primary cause of the increased degradation across these three sites being increased stormwater drainage impacts. Importantly, the good condition of Sassafras Creek shows us that urban land doesn't necessarily need to cause stream degradation if stormwater runoff is prevented from flowing uncontrolled to the stream. So if we look first at Sassafras Creek here, there's very little formal stormwater drainage in the catchment. Most of the roads drain informally to the forest, like in this photo on the top left here, or to earthen drains that allow water to soak into the soils during most rain events. And most roofs drain informally to gardens or to rainwater tanks. These increased flows from hard surfaces are adequately captured by the deep soils of the mountain ash forests of the catchment. Sassafras Township itself does drain to a gully which is eroding and is looking a bit troublesome, but that gully itself seems to be retaining enough sediments that it's still continuing to protect the stream. In contrast, the catchment of Little Stringybark Creek looks like this, more like your typical suburban landscape. Every drop of rain that falls on the roofs that you can see in this photo drain to pipes that flow directly to the stream. Same with the water falling on the road, or for that matter, the soapy water used to wash the car in a driveway on a sunny day. The conventional stormwater drainage causes erosion, pollution and flow disturbance that has degraded Little Stringybark Creek, that is making it look a less happy place than Sassafras. We know that direct drainage connection between a hard surface and stream damages the stream, and effective imperviousness, which is the proportion of a catchment covered by roofs and roads connected to the stream by pipes, is a strong indicator of stream degradation. In the case of Sassafras Creek, despite having 8% of its catchment covered by impervious surfaces, its effective imperviousness is near zero, while Little Stringybark Creek's effective imperviousness is much higher and Brushy Creek's is higher again. So what does direct drainage do to streams? So the primary focus of our past research has been on the way it changes flow regimes. These plots show the patterns of flow in Sassafras Creek, which has little effective imperviousness, and Brushy Creek, which has a lot. And there's a couple of things to note about these. So the scale is stream flow in millimetres per day, so it's the depth of stream flow if you divide the flow in volume in the stream by the catchment area to get depth. So it's similar to the way we measure rainfall. So two things to note. Firstly, the impervious surfaces and sealed drains reduce the opportunity for water to drain into the catchment soils, and so the result is that in Brushy Creek we've got lower base flows. So when it's not raining, we've got less flow in the stream. The connection to the drains greatly increased the amount of flow following small rain events, say 1 to 10 or 15 millimetres. And so we're seeing lots of very high peaks in Brushy Creek, not so much in Sassafras Creek. So in the natural catchments, the response to such small events is pretty small. But in the Brushy Creek catchment, large volumes of polluted runoff flow to the creek every time it rains, just a little bit. So effective imperviousness greatly increases the frequency of both hydraulic and chemical disturbance to streams. And that's the primary impact. And how does this affect water quality, and specifically water quality as measured by the CEP objectives? Well, let's have a look. In streams, polluted concentrations are usually correlated with flows. So each of the points in these plots is a single sample from the stream with its total phosphorus concentration plotted against stream flow. Sorry, I'm having some technical difficulties here. Do you want to have a go at changing that while I continue? And so in each of these plots, we've got a black horizontal line, which is the 75th percentile for that stream, and the orange dashed lines are the objectives for our 75th percentile. And so you can see that Sassafras has a low 75th percentile, Little Stringybark intermediate, and Brushy a higher 75th percentile. So. And they are plotted against stream discharge so each point is plotted against the stream discharge at the time of the sample. And so in a healthy stream like Sassafras Creek, rare high flows carry large concentrations of contaminants. But for almost all of the time during low flows, concentrations of total phosphorus are low. This dominant high quality ambient environment makes Sassafras Creek a healthy environment. So you can see that in all three streams, achieving or failing the 75th percentile concentration, which is the orange horizontal line, is all about what happens during these ambient low flow conditions, which mostly fall below the 75th percentile flow. That's the vertical black lines in each one of these plots. So in Brushy Creek, and to a lesser extent Little Stringybark Creek, stormwater drainage systems raise pollutant concentrations during dry weather and every single time it rains. That's more than 100 times a year in this part of the world. So to protect the stream and to satisfy the CEP objective, the primary focus needs to be on reducing that frequency of disturbance, on keeping stormwater out of the streams during these frequent small storms that pose no flooding risk, and keeping dry weather spills out of the creek as well. So current as well as the proposed standards specify a required reduction in annual pollutant loads from impervious surfaces without reference to a targeted condition in the stream. the implementation of these objectives over the last 20 years have really failed to arrest the degradation of our site on the Yarra River at Templestowe. 20 years ago, it met the signal objective most of the time. Now it does not. This declining condition has most likely been caused by the catchment's infill development, with stormwater drainage built under existing standards. I've lost my ability to. There we are. I don't know. I think I must have sweaty hands. And the decline has been, despite in the Yarra catchment upstream of Templestowe, this decline's been despite quite a lot of investment in the retirement and upgrades of sewage treatment plants upstream, decommissioning of many septic tanks, lots of money spent on riparian revegetation, lots of money being spent on environmental flows. Stormwater runoff remains the major problem that's causing this degradation. The annual pollutant load reduction targets were conceived to protect the bay. Mean annual loads are the concentrations of flow over an entire year, so they integrate over a really long period. That's useful for large water bodies with long retention times like Port Phillip Bay, but it's much less of use for dynamic variable systems like streams. They've never really done a good job of protecting streams. In 2012, we wrote this paper, which provided a critique on the designs of stormwater control measures that have been built to achieve those load reductions, such as stormwater treatment wetlands and biofiltration systems. And we found them wanting. They generally fail to address that frequent flow disturbance problem, allowing frequent storm flows to pass through them with little attenuation. More broadly, loads objectives don't provide guidance on the primary flows which should be targeted for stormwater management for stream protection. If we take Brushy Creek as an example, most of the phosphorus loads, so that's the histogram at the top here, are delivered by high flows above the 75th percentile flow. And yet the primary need to meet our SEP objectives is to reduce the concentrations in the more frequent small flows during dry weather and following frequent small rain events. So let's say our objective is to reduce annual phosphorus loads by 45%. One possible option for doing this would be to completely retain runoff from all small to moderate rain events and remove most of the water completely and release the remainder as well-treated base flow. This would be a good way to go. This would ensure the protection of ambient conditions that the SEP objectives are aiming for. So that's one option. And here we go again. Yeah. I can't do it. Thanks. However, we could equally meet our 45% load reduction target by building a wetland that retains all flows for a short time, removes some of the phosphorus, but has a prolonged release of water with higher than base flow concentrations thereafter. It's a much less satisfactory outcome. Sorry, I need to show you the less satisfactory outcome. So this is something like a wetland might produce. So you're still reducing your loads by 45%, but you're really leaving those concentrations during the low flows unchanged, or potentially even making them worse. Annual pollutant load objectives give us no guidance on which of these two very different options is preferable. If we're to protect stream ecosystems, we need alternative standards that encourage solutions like option A and prevent outcomes like option B that are likely to fail to protect streams. In 2016, Tim and I, together with a group of international colleagues, developed a set of principles for stormwater management for the protection of stream ecosystems, from which we developed an alternative set of stormwater management objectives for stream protection. Briefly, our principles were, that's interesting, no impervious surfaces should drain directly to the streams as the primary flow path. So drainage pipes should be used for flood protection, not for dry weather spill disposal. The drains shouldn't be the first place that water flows to. Runoff from small to as large as possible rain events should be retained to prevent uncontrolled flows to the streams. That is, reduce disturbance frequency. Runoff should be filtered and delivered to the stream in a volume, pattern and quality as close as possible to reference condition. To achieve each of these objectives, it's likely that you're going to need to reduce your total volume of runoff substantially. Now, in the proposed revision of the standards, it's really only this last principle that's been added, volume reduction. But this principle is the only one of the four that doesn't directly affect in-stream processes. We really only included this principle to emphasise that volume reduction is likely to be required to ensure adequate protection of ambient conditions and disturbance regime. The previous three principles are actually of much more direct importance. We aimed to test if such principles were feasible and acceptable to the community and effective at restoring streams. And so to test that, we've used the Little Stringybark Creek catchment to build hundreds of stormwater control measures in partnership with the community and council and with Melbourne Water. We turned these principles into four indices that are averaged to produce a single measure of stormwater control performance, S, the Stormwater Stream Impact Index. The four indices are, each one of these indices is scaled between 0, meaning you're perfectly mimicking our reference or target condition, to 1, where you're essentially doing nothing and it's like conventional drainage with water just going straight down the drain. So we had these four indices that make up the overall index. So there's RO, the runoff index, runoff frequency index, which assesses how often stormwater control measures overflow or bypass, and scales it between the frequency of runoff without any stormwater control and the frequency of rain events big enough to produce overland flow over catchment soils in the reference state. VR is volume reduction index, assessing how much stormwater runoff is kept out of the stream by the stormwater control measure. FV is the filtered volume index, assessing the volume of filtered flows that are delivered at an appropriate rate. And WQ is the water quality index, assessing how close to the SEP objectives for TP, TN and TS the stormwater controller measure achieves. And S is the simple average of these four indices. We've tested the acceptability of this performance standard, and it has successfully been incorporated into sorry. Oh, I don't know what's going on. All right, see if you've got the magic. Oh, Leon, you've got it.
Have I gone too far there?
I think you might have. Yeah, good. No, you haven't gone too far. Beautiful, thank you. I do apologise. So we've tested and trialled and implemented this in the Stringybark Creek catchment through an environmental significance overlay, which has been operating for 5 years now, with broad community acceptance and support. And most importantly, we've found that using this sort of performance standard can restore streams from failing SEP objectives to meeting SEP objectives. The nice thing about the S index is that it can easily be integrated into effective imperviousness. The area of each impervious surface that's treated by a stormwater control measure is weighted by the fraction S. So with the addition of each stormwater control measure in our Little Stringybark Creek catchment, we were able to, or at least in the northern tributary of Little Stringybark Creek, which I'm showing you here, we were able to reduce effective imperviousness substantially from about 6% down to less than 3%. And the response we observed in the stream was consistent with our expectations based on that reduction. Without the stormwater control measures, the Northern Trib failed to meet the SEP objective for total phosphorus, but after implementation of the SCMs, we successfully reduced 75th percentile total phosphorus concentrations to below the SEP objective, and reasonably close to the concentrations that we observed in our forested reference streams, the green bar on the right. So here we have a simple standard for stormwater control that's been tested, showing to be effective at stream protection and accepted by the community. Its use of four indices means that there's some internal redundancy, but also greater flexibility than solely relying on, say, the volume reduction to meet the standard. It's also more directly targets degrading processes of stormwater runoff than loads reductions do. So we're confident that applying a standard like this can truly protect and restore streams. And Tim's now going to tell you how we get there.
Thank you very much, Chris. Exactly, so Chris has set out what we need to do to manage stormwater in a way that we're no longer ubiquitously degrading streams, which is what our current practice does. And so I'm going to try to outline for you, what does that actually look like on the ground? What is it we're building? And most of us, if we know something about water-sensitive urban design, will have a kind of picture like this in mind, where we see all sorts of nice stormwater control measures. I was about to take the laser and point it at the screen here. That would not have helped. Nice sort of vegetated systems that receive stormwater and filter them. And we've got some examples there. A couple from the Little Stringybark Creek project Chris talked about, a couple from a conference presentation in France, and a Melbourne Water generic representation of it. So those things are all nice, but those in themselves are nowhere near enough to do what we need to do. So I'm not criticising those, but really if we want to achieve that outcome of not having frequent stormwater into our stream, therefore not having the hydraulic stress that creates, not having pollution that creates, we really need to start, as Chris said, the prerequisite is we need to take a lot of that volume out. And that all comes down to harvesting. Okay, that's probably not the picture I should have used. That's a different sort of harvesting. We really need to be harvesting that stormwater. There isn't another feasible way to get rid of all that water. You might think, oh, we could just infiltrate it. There isn't going to be enough space in a typical urban environment to do that. And indeed, if we infiltrated that amount of water, we'd have all sorts of unintended consequences. So we need to think about serious stormwater harvesting that can, of course, start at the household scale with rainwater tanks and more sophisticated rainwater tanks, perhaps, or at the larger scale. But again, I want to perhaps get you to think about the things we already do, such as, for example, having a rainwater tank that we water our garden or perhaps use a toilet. Those things are a great start, but we really need to go further. There is a lot of stormwater, and in order to meet those targets that Chris described, we really need to deal with that volume. So we're talking about much more sophisticated and much more ambitious approaches for stormwater harvesting. Here's an example that Melbourne Water and Western Water are working on, which is the Sunbury Integrated Water Management Plan. It involves potentially, it's a project in investigation at the moment and in consultation, but amongst the strategies to be pursued are the idea of harvesting stormwater in a whole range of wetlands around that growth area development around Sunbury, and then transferring that water where it will be then fully treated to potable standards and then injected into the potable network. And so here we're talking about a type of system where we can actually bring that stormwater volume that gets discharged to the creek down to the rate that it would have been naturally, and that allows us to then use our other complementary systems to get that frequency of disturbance and that quality back to their natural level. But of course, we're not all going to be able to build big scale systems like that everywhere, but we can start to think about using technology to create rainwater tanks that are far more clever and sophisticated than currently. So here's an idea that South East Water has developed, and we've been working with them to expand, where you have a rainwater tank that's connected to the Bureau of Meteorology. It's talking to the Bureau all the time. It's providing water to the house for a whole range of uses: clothes washing, toilet flushing, garden, potentially hot water in certain situations. But at the same time, it's releasing a small amount of water to the creek, filtered water, so that you sustain a natural base flow. And similarly, maintaining the same flood management performance, because when it sees a flood coming, days before, it'll start slowly releasing water to create storage for that. So we have opportunities with technology to now create much more sophisticated ways of managing our stormwater harvesting. And if we think about where we could go with that, and the next speaker and Chris and I, so Stephanie Laveau and Chris and I are working on a project with Melbourne Water and South East Water, where we're combining large-scale storages of water with rainwater tanks that will all be connected to each other and talking, and releasing filtered water at the right rate, at the right time of the year to, for example, protect the habitat of platypus. And these are the type of what perhaps seemed revolutionary but now really need to become sort of standard practice if we're to avoid the degradation that's ubiquitously occurred wherever we manage stormwater in that traditional way. What's really important about these type of systems, however, is that they involve interaction with people. So we're not just talking about now Melbourne Water, for example, being the only manager of water. We're talking about everyone with a household potentially having a rainwater tank that not only provides some of their water, but releases water for the needs of the stream, holds back water for the needs of the stream, and that's a really critical point. And so now people become a part of the water management system in the same way that householders are becoming part of the energy production system with solar panels. And that's going to pose some really important questions for how people might be engaged in this process.
So thank you, Leon, Chris and Tim. So now over to how will this work? So I feel a bit like the end of one of those childhood jokes. So we have a stream ecologist and eco-hydrologist and a sociologist go into a public forum, and the stream ecologist says, well, we need to better manage our urban runoff so that we can better protect our streams. And the eco-hydrologist says, well, here's a range of water-sensitive urban design technologies that might get us there. And the sociologist says, well, that's actually not enough. We need to be thinking about the social effectiveness of these technologies as well. We need to be thinking about what are the key issues and the key factors that are going to influence the capacities and the commitments and the understandings of community to be part of this picture of co-management. So I'm posing what might seem a bit of an odd question, really. What might it mean to care for technology? And so I'm thinking about these kinds of technologies that Tim's just described, particularly these real-time controlled networked tanks. So 3 versions of what it might mean to care. So firstly, to appreciate or have an interest in something, to have an inclination towards something. Would you care for a tank with your cup of tea, for example? Secondly, to give attention or serious consideration to something. We need to be thinking about how people are going to interact with, engage with, and live with these technologies. We need to think about this from the moment we start to design these technologies through to their installation, but even beyond that. And so that brings me to the third point here. To care for as in to tend or look after something so that it stays in a good condition. There's a lot of insight on this that came out of that Little Stringy Bark Creek project that my colleagues have mentioned. It's really important that we think about what it is that needs to happen for those tanks, for example, to be cared for so that they continue to perform in the long term, because the story of this technology doesn't end at installation. So a couple of key points of change that I see when we're starting to think about co-management of urban water. A couple of key points I'd like to highlight. So firstly, we're seeing a shift from using big infrastructure on public land, so for example, big dams, big reservoirs, to managing more what I think of as micro infrastructure, for example, those tanks, those rain gardens, not just on public land, but also, as Tim was suggesting, on private land, and private land becoming increasingly important to this story. And in doing so, we're shifting from a centralised model towards a decentralised model of management, because we have these technologies, this infrastructure, scattered, distributed throughout the urban landscape. And that might indeed take us towards hybrid models, where we start to think about how can we deal with those questions of control and coordination that might still be required in order to, for example, coordinate an environmental flow for a waterway. Thirdly, we're seeing that we're layering domestic practices of water saving with practices of water retention and water release. So decisions that were made in a household that might have just been about saving water for consumption within a household actually become a lot more complex when you're making decisions that are also about how can you retain water to mitigate flood and release water for an environmental benefit. And so it's probably becoming clear, this final point then, that the role of private citizens, the role of community, is no longer just about using water, but also about being producers of water. Tim was using the analogy of solar panels on the rooftops, the way in which as householders we're no longer necessarily just users of energy, but also producers of energy. So there's a parallel here. And when we're thinking about what it might mean to manage water as a householder, it's really interesting to see the way in which we've been affected by the Millennium Drought and the ways in which increasingly we find ourselves managing our water use very consciously and planning our water use quite intensively in households. And so this comes from a bit of research we did a couple of years ago in the inner Melbourne area with people talking to us about their experiences of water in their household. And we framed it quite broadly. We want to know what their experiences of water were. And their responses were predominantly about an intense micromanagement of water for water saving. And I use that term micromanagement with acknowledgement of geographer Leslie Head, and she talks about domestic water practices. So you can see here quite a list of different kinds of practices in the household that people talk to us about. And it comes through really nicely in this quote, where this woman's talking about, on the one hand, how often they wash their children, and on the other hand, collecting the rinse water from their vegetables to throw into the garden. There's this real intensity and planning and attention that you can read into these stories of how people are already managing water within their house. But as I said, this is about saving water, and we're looking at much more complex decisions now for multiple benefits, managing water for multiple benefits. So I'd like to finish by pointing towards 3 key challenges that I think we need to address if we're going to move forward with these models of co-management. The first one is the question of the invisibility of water infrastructure. I was just looking behind us here. There's road building going on. I don't know if you've heard it behind us. Infrastructure, the urban backstage, if you like, to our lives. A lot of this infrastructure is hidden from view. So in the case of water, it might be within walls, behind buildings, under roads. We don't see it, and it's out of our mind. And when we talk to people about water infrastructure in the city, you get a lot of question marks. I don't know if you can see it well on that little drawing on the left there. But essentially, this participant in our focus groups was saying, you turn on the tap and water comes from nowhere and it goes to nowhere. And she had a little question mark about the entry and exit point of water into her apartment. So water, something that somebody else has predominantly perhaps taken responsibility, and we didn't even really need to be aware of the infrastructure. We only tend to think about it, frankly, when it goes wrong. And then shifting towards perhaps the right-hand side there, where we might need to take really seriously the question of how can we support people in understanding the built environment as an urban catchment. And a lovely drawing there from another participant who's thinking about the rainwater that falls on her roof and where that flows through the built environment. So to the second challenge that I think we have, that of fitting or refitting, in this case, water tanks into the home. And when I'm thinking about fitting, I'm not thinking just about the physical fit. That is a really important issue. How can we find enough space in an already crowded domestic environment to put a tank? Do we even have ownership of our home that we can make such a decision? I'm thinking beyond financial fit. These are important questions too, the costs of tank and of maintenance, and also how we might design particular economic incentives to help make that financial fit to get these technologies into domestic settings. But I'm much more interested in this, the fit with domestic practices. What is it going to mean to live with these technologies, to live alongside these technologies and interact with these technologies, particularly as you've been gathering now, where the role of these tanks becomes quite multi-purpose, and that we're asking of people to be involved in decisions for a public good that's coming from their private space. As the third and final one, trust. And I think we've got a legacy here that we have to acknowledge, particularly coming out of the Millennium Drought and hearing stories from some of those participants I mentioned earlier who really have invested a lot in what they've done around their homes in terms of water saving, usually for personal consumptive use. And there's sometimes the feelings of frustration and futility where you see bad practice elsewhere around you, whether that's the person that's hosing down their driveway or washing their mountain bike, the soapy water down into the stormwater, or whether it be reporting a water leak on public land and nothing happens and you still see that water draining down the road. So there's trust that the others around you are doing their part. Then there's trust about letting people into the home, because what we're talking about here in these kinds of solutions really blur those boundaries between the public and the private. Trust in letting people into your home, and I mean both metaphorically or virtually as well as physically. So obviously physically in terms of things like potentially gaining access for maintaining technologies, but also remotely or virtually through some of these technologies that we're talking about, where you might have a device that's making decisions for you that might require access to data about your water use, for example. And then finally, trust in terms of believing in an ongoing and collective commitment to this, so that this isn't just a flash in the pan, but actually, as I'm saying, a lot of this is around thinking through the long-term performance. So trust that all this effort that you're putting in, all this change that you're managing is actually part of a bigger ongoing commitment. So just to summarise, so we've come to the end here, and I suppose my argument is that it's really important that we think about the ecological effectiveness of these technologies and how well they're benefiting our streams. It's really important that we think about how well they work technically. But we also need to think about the social life of these technologies. We need to think about what it might mean to care for these technologies in the current moment, but also well into the future. We need to think about the ways in which these technologies fit into private lives, how we're going to live alongside these devices. We need to think about the distribution of responsibility in co-management. And by that, I don't just mean between people, but also between some of the smart technologies themselves having responsibility. And we need to think about the social relations of urban water management and the ways in which these technologies make new relationships, whether that be between actors within urban water management, whether that be between the private and the public, or even between communities and their waterways themselves. Thank you.
Well, thank you to all three of you with some really stimulating thoughts and topics there. And questions are coming in, but I'll take my opportunity to ask the first question to you, Stephanie. You mentioned the Millennium Drought, and that brought a real focus to people and onto their management of water and sort of harvesting it carefully and using it carefully. I was conscious of doing that myself, and I think I was starting from a pretty high level of awareness. But what about what's happened since? Like to my mind, once the rain started falling, a lot of the impetus or desire, maybe, or the awareness has gone away. Is it something that? How do we keep up that level of focus and awareness and care, I guess?
It's a question from you rather than from the floor, is it?
Yeah.
It reminds me, just to tell a little story, I left Melbourne back in 2009 to go live in the UK, so it was just at the end of the Millennium Drought. And then I came back 7 years later, and it was really interesting to meet my colleagues and hear a totally new story about water. So I'd left in this moment where it was all about water saving, that's the big thing. And then coming back and hearing, well, actually, the biggest threat to our urban waterways is stormwater. And so it is really interesting, because I think the Millennium Drought, I don't want to say we were indoctrinated, but we were so carefully engaged with water saving as a frame for what we do in our homes. And I do think that a lot of those kinds of practices and technologies and things are sort of, they're dormant, waiting, and when we have focus groups with people about experiences of water in the home, they are often referring to ongoing commitments and still having these technologies around, the water saving devices in the showers, etc., ready, to sort of jump into action. But I think that actually, when we're thinking about urban stormwater, it's a real challenge for us because it's a whole nother layer of decision making that has to go on. It's a lot more complex. You're making decisions in your home now, not just about how to save water for your consumptive use, but how to retain water to stop floods, and how to work with water in a way that's going to be more beneficial for our urban streams.
Could I just make the observation that I didn't see a huge difference between the Millennium Drought and after the Millennium Drought, because even during the Millennium Drought there was way too much stormwater. Stormwater was still a problem. It still rained during the Millennium Drought, maybe 90 days a year rather than 100 days a year, and that was still a frequent disturbance to our streams. And so, and if we look at the volumes of water that fell during the Millennium Drought, the amount of excess stormwater runoff in Melbourne's in the Melbourne area still was about the volume of water that we were importing from our reservoirs for our use. So it's
Gives you a sense of the opportunity.
A real shift in the attention, though.
Yeah.
So the way in which now, in the last 10 years or so, that stormwater is really rising up the agenda.
Well, here's a question from the audience, which is quite an interesting one. If private citizens are considered as producers of water, does that also make them liable for the excess discharges to waterways?
I would like to see, as far as I'm concerned, we need to start thinking of stormwater that runs off an impervious surface that you've built. By building that impervious surface, if you connect that directly to the stormwater drain, then you have become a polluter. And I would like to see some incentives, regulation, something that would would make people think that there's an alternative way. I don't actually have to have this connected directly to the stream. There are lots of benefits for doing it a different way.
So, like a follow-up question from this questioner is, could there be an introduction of a stormwater levy? Now, we do pay Melbourne Water, part of our rates is something to do with stormwater. So is that in effect some sort of levy, or would there be a different fee? If you're generating a lot of stormwater, you pay for it. If you're not,
Actually, I feel like the dichotomy between wastewater and stormwater is really interesting, isn't it? Wastewater, we're charged broadly based on how much we produce. It's a little bit vague. It's based on a ratio of your use of potable water, and that's assumed to be wastewater. But broadly, the principle is you pay for the amount of polluted wastewater you produce. As you say, there's a waterway management charge or a Parks and Waterways charge in different parts of Victoria. It's got different titles and there's different amounts. But none of them give you a performance incentive to do exactly what Chris described, to reduce the amount of stormwater you produce, to manage it properly, to treat it properly, to do all of those things. There are many places in the world that are trying to do that and are doing it successfully. But here we do so little to make people aware of the impacts of stormwater, other than just, to them it just looks like a tax, because it doesn't matter what they do to their stormwater, they'll still pay the same amount.
And a levy is only going to work if that levy goes towards treating your runoff from your property further downstream. And in many cases, that's not going to be possible, in which case it doesn't make a lot of sense.
a question from Liam from Bendigo. Community co-management is an interesting premise. However, is the water industry ready to share power and responsibility with the community? And if not, what barriers may exist to realise this opportunity?
So I actually think that we don't know a lot of the answers to a lot of these questions around co-management. I felt when I sort of set it up a bit as the three people walk into a bar joke, I was very conscious of the fact that I don't have a punchline, that actually I'm raising more questions than answering, because I think we're actually now in the space where we will be figuring out what co-management might mean in practice, because there are lots of different ways that we could go with this. And I think that coming back to the previous question about what it might mean for community to be producers of water, and we've used the solar situation as a bit of an analogy, but actually the stormwater situation is even more complex than that, because it doesn't require the kind of coordination that we need for urban stormwater, because it's one thing to have these bits of infrastructure distributed and to be sort of managing them in different places, but we're actually also thinking about how to control and coordinate them for particular outcomes. So it is, I think, a very complex domain. Really pleased we've got some excellent partners that we'll be working with on this Monbulk Creek project.
Because it does sound like you guys have worked with water authorities.
Yeah.
So it sounds like there's a willingness and interest. And
Yep.
Of course, yes, and certainly I think Melbourne Water are certainly giving this a red hot go with their Healthy Waterway strategy, which is very heavily co-designed with the community and partners, and so they're giving it a crack. But, but as Steph said, there's lots of unknowns. It's the pioneering approach.
And I might just make a quick plug for Southeast Water, because I get a commission each time I do. No joke, absolute joke. But they developed that tank talk technology that allows these tanks to interact with the Bureau of Meteorology and to be operated adaptively. And they've developed a whole technology division that's trying to do this. And I would say, of course, there'll be some industry players who say, no, we're the centralised water provider and that's how it shall be forever. But I think there are others, like Southeast Water, who see the future and realise, just as in the energy game, you either see the future and try to create it, and then you have your role as a technology provider, and or you sit there and wait for other things to come over the top of you. So I'm not as pessimistic as Liam from Bendigo that the water industry is not ready. I think there are certainly members amongst them who are really pioneering, and I think that will take the rest. And overall, I would argue the water industry in Australia is pretty innovative and creative.
Maybe it's a related question, but building some of these requirements into our planning systems or codes, I don't know what you've got. Have you got any experience or able to comment on embedding some of these requirements into the planning codes and pluses and minuses, the difficulties or whatever?
Well, we've certainly trialled with our environmental significance overlay in Little Stringybark Creek. We have got these sorts of requirements in the planning scheme for a very small part of Melbourne. We've had a few teething problems, but generally I think we'd rate it as a success, and certainly well accepted by the community. The proof is in the pudding of the streams, where we have shown a response that we'd hoped we'd see. Does that adequately answer the question? Yeah.
I suppose I'd also point to the issue of compliance. So it's one thing to have provisions at the planning level, but you also need to be putting resources into monitoring compliance with those planning regulations, and that's something I feel really could do with a bit more work.
Yes, indeed.
Now, a question from Jacqueline, who's interested to find out a bit more about the Stringybark Creek project, which used a range of mechanisms. Were any of them more or less effective than others? Was there more impactful of reducing runoff volume or in partially treating stormwater? Any further impacts of these on improving stream health?
Good question, Jacqueline. So of course I had to give a very abbreviated story of Little Stringybark Creek, and I showed the results for the northern tributary of Little Stringybark Creek, where we have shown some success, and we have successfully reduced runoff frequency as we'd hoped, and that was because in that northern tributary we did have a large harvesting scheme. In the other tributaries of Little Stringybark Creek, we've been less successful, and I put that down to two difficulties. Two primary difficulties. One is a lack of space. So we're dealing with an urban area that's already been planned, and there's an infuriating number of stormwater pipes in the Little Stringybark Creek catchment that drain through people's backyards, and so you've got people's back fence and then the stream, and so there's no space to put systems at the bottom of pipes, and so it's a planning problem in the existing fabric that was very much a difficulty, and then our second problem was a lack of demand. And so we put in heaps of rainwater tanks now, literally hundreds and hundreds of rainwater tanks, or I think over 1,000 actually, of rainwater tanks. But even with those systems, that wasn't using as much water as we require. And so so I guess to answer, it's a long way around to answering Jacqueline's question. I think we have shown that you can be most effective where you can keep more water out of the stream, where you do have enough demand to keep water out of the stream, to allow your filtration systems to work more efficiently.
Yeah.
Okay.
And that harvesting has to be for uses that are taking water right throughout the year. The classic thing we're all used to is a rainwater tank that you use for watering your garden, which means it runs out of water in summer when you want it, and all of winter it's just overflowing and going straight into the stormwater system. So our systems that supplied toilet flushing, provided clothes washing, provided hot water with appropriate treatment, and in one case provided a car washer in a petrol station. Those work really well because every day that tank's getting drawn down.
So having a range of options is really good.
Yeah.
To use water.
And we used a lot of leaky tanks as well. So with tanks that had deliberate leaks in them, so that they were just leaking into the garden at a very low rate, so that they were drawing down even if there wasn't a lot of use in the house.
Now, continuing on with Stringybark Creek, a question from Harrison from Sydney. Did you see a change in the ecological indices in relation to the work there?
That is as yet an emerging story. We haven't done the full analyses on our biological data yet, but I think looking at the data, no, we haven't seen as big a changes in the biological community as we'd hoped.
Did you apply your stormwater index to that as well?
Yeah, that's right. But so in, say, the Northern Tributary, where we would expect to have seen a change, it does look like we're seeing greater abundances of sensitive taxa, sensitive species. So that's good. But what we're not seeing at all are recolonisation of missing species.
Right.
So we're not getting recruits in, which is a bit surprising because it is pretty much a forested landscape around Little Stringybark Creek. So I would have thought we'd have lots of potential for recruits, but we're not seeing it. So when it comes to measures like signal, which are all about presence or absence of families, we're not seeing a change in signal because we're not getting those new species. We're just getting changes in the abundances. So it's a bit early days to be making strong conclusions on what's happened there, but initially we haven't yet seen strong ecological responses. No.
Yeah, and I guess streams can be impacted in an instant, but can take a long time to recover.
Indeed.
So we've got to allow some lag.
Yes.
And that sort of thing.
Yeah. So, but at this stage we're looking at a 5-year lag, and not much has happened. So, so we shall see.
Harrison from Sydney has prompted me to think about. Is Sydney or any other Australian city doing better than Melbourne? Can we stir these competitive juices?
One for you, Tim.
I don't have a strong sense of this. I get asked this question kind of all around the world in a way. And I always think that there's lots of good things happening in lots of cities. So Melbourne often gets described as a leader, mainly by Melburnians, I find. And so I'm not that convinced of it. You go to Sydney and see some really creative, interesting things. I work a lot in France and there's some really great stuff happening. And I think there's some great stuff happening here. So yeah, I can't really, and Brisbane's got heaps of great stuff. Western Australia, there's a lot happening. So I think you'll find really good innovators in water sensitive urban design, all around the world, and we should jump on their wagon.
Yeah, but I think what we're missing all around the world, and including Melbourne, are these sorts of technologies. In fact, I feel like I'm overstating what they are by calling them technologies. A lot of the time, it's really just not putting in a stormwater drain if you don't really need it. But what we're not seeing are these sorts of solutions being applied at a catchment scale anywhere in the world, really. I mean, Little Stringybark Creek is probably the first case where that's been tried. Yeah. Sunbury is another example. Yeah. In Sydney, South Creek, they're working hard to do things right in South Creek, but that's a much bigger catchment with much bigger challenges. And so
and there's some promising things around the Aerotropolis in general, the Western Sydney Aerotropolis.
Steffi?
I suppose just to complicate it a bit, when we're thinking about who's a leader and who's not a leader, which city does better, it's really important that we're constantly asking that question of what success is and how we define success. So there are competing stories that can be told. If you look at Melbourne and think that we're a leader, if you're thinking about the number of installations that there are in the urban landscape, if you change the question and you think about, well, what's the functionality of these things that have been installed, how well are they performing over time, then you might get a different result. So it's really important that we constantly ask that question of what is success.
Very true. One question which I have is, we also encourage to recycle water, and our treatment plants do a good job of recycling water. And I've often heard it said that reusing recycled water is in competition with reusing stormwater or doing something with stormwater. Do you have a perspectives on this? Like, are they complementary? Are they in conflict?
They potentially can be in conflict, I think. Ultimately, the volume of stormwater we want to be keeping out of our streams is pretty much the same as our demand. And so if we were serious about finding an alternative water source, I'd say we should be putting stormwater first. And to date, in many places, that hasn't happened. It's wastewater has come first, I think, at the detriment of stormwater. Perhaps there are circumstances where they needn't be in competition.
It makes me think about the big picture planning as well. So that the concept you're describing, Chris, is where we're trying to retain and use that stormwater within the urban landscape. But if we had more of a European style of development where we had, I'll call it village, but anyway, urban centre surrounded by agriculture, then we could potentially harvest all of that stormwater and combine it with wastewater to meet those very large demands for agricultural water. That would have huge advantages for the resilience of our agriculture, as well as kind of effectively deal with that conflict. But the way we have it now, of this sort of, you've got this Melbourne that just grows out and out and out, it's impossible to do that. And then we do have wastewater and stormwater directly in conflict. You just can't find enough uses for all that water.
But of course, that does raise opportunities for our regional cities, which of course the stormwater standards are about as well. It's not just about Melbourne, is it?
For sure. Actually, just immediately following on to that, is there any difference between Melbourne and cities like Ballarat, Bendigo? Is the nature of the problem different?
The only thing I would say is that downstream of towns, you give Ballarat and Bendigo as the examples, downstream of those towns you tend to then have rivers, well, you don't tend to, you do have rivers flowing through agricultural land use, and there's expectations about, there's a demand for that water. And so then you potentially get into conflicts where for the stream the best thing would be to hold that water back, but agricultural water users may want that because they might rely on that harvest for winter fill storages. So that can be a bit of a complication.
Right.
I did gloss over our first principle. In fact, I didn't even mention our first principle from our principles paper, which was decide what it is you're trying to protect first.
Right.
And if your urban area is flowing directly to the coast, then all our arguments about streams and rivers, they don't really count, and your loads objectives are going to be fine.
Absolutely.
So for somewhere like Warrnambool, for instance, where it's either the Southern Ocean or the Hopkins Estuary, there's probably a certain set of objectives for them. For some of the smaller streams that flow through Warrnambool, then you'd be looking at different objectives if you're interested in saving or protecting those streams. So it's all about your receiving ecosystem, I would say.
There's been a big influx in questions. I'm trying to keep up with them now. But somebody's asking, I'd like to know how micromanaging decisions can be made. I agree with the importance of thinking about trust from households to people and agencies managing their tanks remotely, but what about trust from Melbourne Water and other agencies to the households and their micromanaging decisions? How are differences in criteria for decisions, how would they be negotiated?
Well, can I just put question mark, question mark, question mark? I think as Tim was saying, this really is a pioneering field, and I don't think we necessarily have the answer to a lot of these questions. But I suppose for me it's a question firstly of what are the different options for the way in which the decisions get distributed. So as I said, part of that's about people's decision making, would that be in the home or Melbourne Water in the office, but also about the decisions that you're embedding within the technologies themselves.
Yeah. It becomes much more complex, doesn't it? As like your comparison with the solar and stuff, I thought, putting electrons and then they go along power lines is kind of simple. But here it's there's a lot more steps along the way, a lot more pathways, and there's ecosystems to protect.
Especially when those multiple benefits we're talking about wouldn't even necessarily line up in terms of what decision you should make in a particular moment in time.
I hate to be the kind of economist in the room, but I suppose a market economist would argue if you send the right price signals, you'll broadly get the behaviours you want. So if, for example, rather than just having a straight waterway charge or parks and waterways charge, you charge people for stormwater management in the way you do for wastewater, then there's already a behaviour. If you then reward people with tanks for their, for example, releases of environmental flows to support platypus, in the same way you reward people for their release of electrons to support the grid, then you start to get the behaviours that you want. So, I'm not sure I'm a market economist by mind, but I think there's a fair argument there.
Okay, a question from Simon in Melbourne. A lot of the examples you gave was about nutrients and mitigating flows. What about other contaminants in stormwater to improve ecosystem health, and can you comment on that?
Yep, sure. So I think we go back to the premises behind the SEP objectives. Really, we've settled on a small number of pollutants that can be surrogates for a large number of pollutants, and so stormwater, the pollution problem in stormwater is extremely complex, and so there's a recent paper by Sujay Kaushal and colleagues from Baltimore in the US that they called or something about the cocktail of stormwater pollutants, and they list, and it's literally hundreds and hundreds of pollutants that are associated with stormwater, and if we start thinking about each one of those, it really and thinking about how to manage this pollutant or that pollutant, it really becomes an intractable question. And so the cleverness behind settling on things like total nitrogen, total phosphorus, and total suspended solids, for instance, is that particularly phosphorus and suspended solids are good surrogates for heaps of pollutants that attach to particles.
Yep.
And so if we manage for phosphorus, we're probably doing a good job for a whole lot of the other sorts of pollutants. And then nitrogen is predominantly nitrate, which doesn't attach to particles very well and flows through soils, and so for more mobile pollutants, nitrogen is a good surrogate for those. So our view is that if you manage for those pollutants, you're likely to be doing a good job for the general bulk. And of course, the more obvious solution that we push, number one, is keep the water out of the system altogether. If you're keeping the water out, you're by definition keeping all the pollutants out. So.
All of them. Yeah, exactly.
There's a couple of, I think, related questions from Teresa from Melbourne and Caroline from Melbourne about there's a lot of the emphasis has been on water harvesting and planned release from domestic areas, but applying this surely the same sort of thinking should be applied to sports grounds, schools, airports, freeways. I assume you'd agree with that, or?
Yeah, completely. Yeah, I definitely would have covered that. I had 10 minutes, but 3 of it was stolen by Chris. With my permission, I must say.
And my technology.
But yeah, really fair point. So we're trying to create a sense of what's possible just with a couple of examples. But I agree, it should be everywhere. In fact, it should be the standard practice in the same way. Whenever we do anything that involves wastewater, we deal with it.
Yep.
And if we had the same attitude to stormwater, whenever we produce stormwater, we deal with it. So yeah, absolutely. Airport, runways, sports grounds, car parks, dog training facilities, everything.
What about Dale from Melbourne? What is the single most important question What's the single most important change to policy or legislation which we could make to significantly improve stream health, I assume in the context of stormwater?
Dale, that's a very difficult question. Do you want to have a go, Tim?
I'm going to guess at the surname. Well, I would say the single, and actually this really, you should have taken up this Dorothy Dix question, I reckon. The single most effective thing we could do, I think, is to implement those objectives statewide, including having them included in the Victorian planning provision. In the same way Clause 56 imposes, and now Clause 57 too, I think, imposes those load reduction targets. So if basically every development had to demonstrate that it maintains the runoff frequency at the current rate, it maintains the runoff volume at the current rate, it has the same volume, overall runoff volume, and that the water quality concentrations are the same, so and meets SEP. If that was a requirement of all planning through the VPP, and exactly as Steph said, that goes all the way down to the plumbing inspectors, etc., the building inspectors, so that when you get your building permit, it's complied with, then that would absolutely change the world. Well, would change Victoria as well.
Yeah.
I think
And Dale's from Melbourne, so that's right.
There are two games here. There's the short game and the long game, and I think the short game is about protecting those catchments and streams that haven't been developed yet. So the greenfield areas where we're draining to streams that are still in good condition, and we desperately need good, strong planning law to make sure that those new systems are those new developments are built in a way that are not going to degrade our streams. And we're having some success in places like Sunbury, and in less success in others, and probably more less success than some success. But the longer game is the existing urban fabric, and you know, we've had a crack at restoring Little Stringybark Creek and had a small amount of optimistic success there, but it was quite expensive. It was a very expensive experiment that we ran, and you really couldn't roll out what we did in Little Stringybark Creek across Melbourne to look at restoration in the next few years. And so what we do need is to say take a 50 to 100 year look into the future and say what could Melbourne look like in 100 years. And if we think about how often building stock and road stock gets turned over, it's something of the order of 50 or 100 years. Yep. And so in 50 or 100 years, we're going to have a completely new urban fabric here. Yeah. We need strong planning and building regulation now that will incrementally reduce that urban stormwater problem over the next decade, so that in 100 years' time, perhaps we can be looking at a healthy Gardeners Creek, a healthy Darebin Creek.
It's interesting that we often say, for pristine areas, let's have strict targets. But for our more inner areas, they're already gone, so let's not impose too much. I sort of get that, but on the other side, we're basically saying in 100 years, we don't have an aspiration for them to be any better than they are now, and that seems a bit unjust on future generations, because if they want to recover it, we're asking them to not only undo what we've done to date, but all the stuff that's going to happen in the future.
One of the questions which I hear about occasionally is that, in a warming climate, less rainfall, higher temperatures, having green and blue spaces in our urban landscape is going to become really important for humans, let alone ecosystems. Have you had any experience with this, or can think about the benefits from such developments are from a human perspective?
I think we'd class that as a Dorothy Dix early on.
You're looking to me.
Oh no, I'm happy. But
Anyone?
Well, I'll start. So I think it's a really important point, and actually, Steph and I were having a conversation before about whether people are engaged by the conversation about stormwater, and I think in the stormwater industry, a lot of people have tried to actually connect people to those more human benefits, that water in the landscape, supported vegetation, trees, shade, You know, you walk down those lovely streets of Toorak thinking, oh yeah, I might buy that house and that house. And it's the trees that make those streets so beautiful, and it's water that's necessary to support those. And so I think it's absolutely true. And yes, it's the thing that'll probably get decision makers on board too. So it's, you know, it's kind of got a political advantage, but it is so fundamental. If you think about the most vegetation depauperate suburbs in Melbourne, they really are very uncomfortable places to live during you know, those extreme heat periods. And I think that's a very significant moral choice for a city to make, to leave you know, some areas like that. And stormwater presents a really great opportunity through passive irrigation, etc., to create these landscapes that reduce heat stress, reduce therefore the loading on the health system. You know, there's lots of data about that, as well as data on effects on people's, you know, mental health.
Yeah, that's what I was going to add as well. So those physical well-being aspects, we have colleagues who work a lot on the mental well-being that is associated with being near these blue-green spaces.
Yeah.
So in our principles paper, we spend quite a bit of time on, you know, going through the various co-benefits, but we do signal a warning that we really need to keep our eye on stream protection and restoration. And if we design our stormwater management to protect our streams, we're going to achieve these co-benefits. Often, if the co-benefits come first, the stream can still get clapped out. So,
okay. Yeah, we have to. The question is, what are we trying to protect, or what are we trying, you know, keep the focus and be clear about it anyway.
Yep.
I think we're running out of time, but one final question from Ross. In the water industry, we are finding that cost prohibits us from creating larger centralised stormwater harvesting systems, i.e. other forms of water are cheaper to produce. Where do you think we will have to go to make this an option that water authorities will accept?
Sunbury?
So a case study, in other words?
Yeah, and I believe the economics of Sunbury stacked up, you know, so it was the first thing they assessed, and so harvesting water from Sunbury was cheaper than other options. So, so that was the first box ticked in that case. But of course, that is not going to be the case everywhere. So
because it's a long way from the sort of dominant sources of Melbourne's water. But again, I think if we start to think about how are people charged for the way stormwater is managed, you know, in wastewater treatment, we don't go, oh, it's too expensive to build a treatment plant, so we won't. We say we need to build a treatment plant, so we need to be charging appropriately to be able to afford that investment to protect the environment. If we thought about stormwater in the same way, we could easily then say, you know, a lot of individual houses aren't going to be able to treat stormwater the way they are required to, but they could contribute in the way they would for wastewater to a fund that then funds a regional scale harvesting system.
Okay. I think we're coming up to the end. I think there's just a minute or two left. I'll just finish up by saying thanks to everyone. As Caroline mentioned, you know, EPA gets lots of pollution calls about the stormwater system delivering pollutants to our waterways. So often EPA is at the pointy end of acute events, trying to manage that. You know, I've been involved in a couple in recent times which present quite different aspects because of the stormwater system. Everyone probably remembers the big fire out in the western suburbs, which the chemicals were there and it took a long time to put out, and it was also about 10 metres away from Stony Creek, and this fire water went into Stony Creek. It was a real toxic brew, and it was terrible, you know, and had immediate, severe, long-lasting effects. Now, there was a similar fire up in the northern suburbs about a year later. Not identical case study. They're not, you know, there's difference in size, but still a chemical warehouse fire. But the stormwater system was effectively disconnected from it. It went about 750 metres to a wetland, which could be switched off. So a constructed system, and water could be stockpiled in the wetland and then pumped to sewer. And Milston Creek was the closest creek and had basically no impact. So, you know, We talk about urban renewal, and I think it'd be lovely if that sort of system was in place so that in future these high risk sites, aren't in the Stony Creek situation, but in the Merleston Creek situation, where they're at least given a chance, because accidents will happen. And of course, in the longer term, hopefully we'll have the more ongoing benefits and controls that you've talked about a lot and researched a lot in order for that longer term benefits to our streams and the overall environment. So I'd like to finish up by thanking the three of you for a really good, stimulating talk. I'd like to remind everyone who's listening that the next EPA Environmental Science Seminar Series will be in May. It's going to be on climate change and environmental public health, so maybe some overlap in stuff we've talked about today. And so I hope you all sign up for that. We have been capturing the questions. I haven't been able to ask all of them, so we'll try and get back to the people who've posted them with answers. So thank you again, everyone. And I'd like to thank our speakers once more. Thanks,
Leo.
Thank you, Leo.